Hi, Steve Stedman here, and today we're going to go through a quick demo of how tables and indexes work in Microsoft SQL Server. So to start out, we've got a table called people, and we just did create table. We did not put a clustered index on it, so it is an unclustered table, meaning it's a heap. And the way things are organized in this just happens to be just wherever they ended up when the insert happens. Over time, things get deleted and things get added and things get changed, and you end up with just kind of an overall random ordering of the things that are in this table. Nothing is sorted, and there's no specific order to any of it. And what that means is that the only way to get anything out of this table is then to go and search every single row. If I wanted to find all the people in the table whose name was Alex, I would start by looking at column B and say, is this Alex? I say I. The SQL query optimizer would do this. Is this Alex? No. Is this Alex? Yes. And this is what the query engine is going to have to do in SQL Server in order to find your data. Going through, is this Alex? Is this Alex? Is this Alex? All the way down. And anything that matches Alex is going to go into your result set at that point. The only way it can get that is to scan every single row in that table, because there's no logical or no specific sort order to it. And it could be the very last row, it could be an Alex, the very first row could be an Alex, whatever. The only way to get that is to search. So another thing on this is that if we want to look it up by ID and say, show me all the people who have an ID of 11, I would start at the top and say, is this one 11? Is this one 11? Is this one 11? And go all the way through. Oh, there's an 11. We'll throw that in the result sets. Keep going down. There's no other 11s. That is what is known as a table scan, where it's scanning the entire table to get the results. Now, if you have 15 million rows in this table, it's going to scan all 15 million rows, even if there's only one ID of 11 in the whole table. It's got to search them all to confirm that there are not multiple. This is a heap. It's an unordered list. Things just end up in the table and whatever they end up in the table as. So the unclustered table or a heap is really not a very efficient way to access data in SQL Server, or in any system. So what Microsoft came up with, or maybe it was before they acquired SQL Server, what they have is a concept of a clustered index, where a clustered index basically takes your entire table and sorts it on something. So in this example, I'm going to add a clustered index on ID. And when I add that, you can see the whole table now gets sorted by the ID column. So what this means is that if I want to look up anything by what it's clustered on, by ID, it's really quick to do it. If I want to look up who is at position 18, through the B tree structure that makes up an index, it can quickly get to row 18 with just a couple of page reads and determine 18 is Fred and return that back without having to scan through the millions and millions of rows that might be in a table. This one only has 22, or actually only has 16 rows in it. Imagine if it had 15 million instead of 16. There'd be a whole lot more work going on here. Then let's say if we want to search on name. I want to find everyone in the list whose name is Bob. Well, because we have no index, no clustering on name, we have to scan through the entire table. And in the case of a 15 million row table, go all the way down and say, okay, here's all the Bobs. And in this case, 1 out of the 16 would be returned. If we want to search on a phone number, we have to search through the entire table and say which phone number matches the one we're looking for. That is not a very efficient way to search, but with just a clustered index on a table, we've got it all sorted by some specific value. In this case, the value is ID. And the clustered index needs to be clustered on something that is unique and generally increasing, although it doesn't have to be increasing, something that would commonly be used for looking things up. Now, if we're going to do a join between this table and we're joining on ID here to something somewhere else, that's going to make it so it's really quick to access the data in this table. But if we were trying to join on name, it would be really slow, or trying to search on name may be really slow. So that's where they come up with non-clustered indexes. And what a non-clustered index, well, first I guess I should say on a clustered index, you can only ever have one clustered index on any given table because it changes the entire sort order of the table. And the table can only be sorted in one order. We can't have it sorted by ID and sorted by name. It just won't work. So they came up with a concept of a non-clustered index. And what a non-clustered index does, we'll add one of those here, is it creates a specific copy. In this case, it's a non-clustered index on the column name. It creates a copy of everything from the name column sorted and accessible quickly through a B-tree structure. And then it also contains the value in the clustered index in order to be able to go back and look it up in the original table. Now, you can create a non-clustered index on a table that is a heap. There's just an extra step that has to go in there. It doesn't actually have the clustered index value, but it has a row ID to be able to go look it up. And it's not quite as fast as having a clustered index, but it does work. In this case, prior to adding the non-clustered index, if we wanted to search by name, say give me everyone in the list whose name was George, well, we would have had to go to the clustered index and do an entire table scan. Scan is when it searches everything. A seek is when it goes to a specific row. But we'd have to do an entire table scan, and imagine if this was 15 million rows, we'd have to go through all 15 million of them. Let's say we're searching on the name, I don't remember what I just said a minute ago, the name George, and we have the non-clustered index. Well, this whole list is sorted by name, and it can immediately jump through a couple of page reads through the B-tree structure to get to George in the list. Even if there's 15 million there, it can say that George has an ID of 7, and then because over here we can look up quickly by ID, we can look up the entire row for George based off of the ID of 7 there. The non-clustered index gives us a quick way to look up the ID and jump back to the clustered index and get all the data that you needed. If you were just testing if a name existed in the list and you wanted to say how many Bobs there were, or are there any Bobs, well, you could get all of that out of the non-clustered index here without ever having going back to the clustered index at all, because that data is contained there. You can have multiple non-clustered indexes on any table in SQL Server. So here, let's go ahead and create another one on phone number. If we want to search on address, for instance, the only way we have to search on address is to go to the clustered index, the table itself, and search through all the rows given a specific address. Prior to adding the non-clustered index on phone number would have been the same thing. We'd have to go and search for phone number by looking at every single row. But now, if we want to look up who has a phone number of 360-123-3823, well, we can look here and say that's 17. The ID of 17 can be quickly accessed, and now we go back there, and there's somebody named Sky. If we want to look up who has the phone number of 360-322-3004, well, you'd look there, quickly access that through the non-clustered index. We can see that that's a value of 19. 19 is Juan, and there we go. We can look up all the data based off of Juan there. Now that we've added non-clustered indexes, we can quickly search on any of those values that are included in the non-clustered index. Now, you want to be careful because some people look at this and they just say, oh, if I have a table with 50 columns, why don't I just add one non-clustered index on every one of those 50 columns, and then magically I'll be able to search every column quickly and easily? Well, it doesn't quite work that way, because when the SQL Query Optimizer runs and it figures out what it's going to use in order to be able to access your data and get your query results, it can only ever use one non-clustered index at a time per query. If you're querying and you're asking for where the person's name equals something here and the person's phone number equals something here, it's only going to use one of these two non-clustered indexes, not both of them. And that's why you can set up composite non-clustered indexes that contain name and phone number rather than just a standalone one like we've got here that has name, or one that just has phone number. I don't have a screenshot showing that, but it would be conceptually the non-clustered index would have more columns than just the two columns we're showing here. It would have 3 or 4 or 5, depending on how many things you added to it. One of those things, it's important to understand what it is that you're commonly querying or joining on. And anything that you've got in your where clause that you're evaluating against and filtering on, or that you have in a join predicate that you're connecting tables through a join, you need to make sure that if you want those things to run quickly, that either your table is small and you don't care about indexes, or if your table gets big, you want to have indexes on the right thing so that your queries can run quickly. If you like what you've seen here, I would encourage you to take a look at our SQL Server Performance Tuning class. This is one of the most comprehensive classes that we have at Stedman SQL School. And you can get there with a shortcut URL of stedman.us/performance class. Take a look at what's all in this class. You're going to learn about performance tuning on SQL Server, it's a welcome and overview, how we made the course. We're going to go into detail on execution plans and what's important to know about execution plans and how to figure out what's slow in your query. We're going to take a look at some things with sargeability and we're going to look at some indexing strategies, index overview, and then we're going to go in to talk about some code smells. And what code smells are things that it's like you walk into some place that's got bad fish and it smells just off. And there's things in the code that we refer to that way. Things like functions in the where clause, parameter sniffing, things like that, implicit conversions. Then we go on to database design considerations, performance monitoring, how we can track and know if our performance is improving, isolation levels, some more tempdb things, missing indexes, and then we wrap it up at that point. This is a class, one of my most comprehensive classes that we've built at Stedman SQL School. I hope you check it out, sign up, and learn about performance tuning. Thanks. Have a great day.